Hello everyone and welcome back. Today we will continue the fifth module of this course which deals with object-oriented programming. We will start with UML diagrams. UML, which stands for Unified Modeling Language, is used for planning class relationships in object-oriented design. It helps illustrate different aspects of class relationships. It is a versatile, flexible, and user-friendly method for visualizing a system's design. So you can go Google UML diagram, and you can check it out here, Geeks for Geeks. This is a very credible website for programming, so you can consult this website whenever you need some help. So this is UML, and these are the types of UML diagrams. We have two distinct types, behavioral and structural. You can see it here. So you can read about it online. PyCharm, in fact, has its very own UML tool which supports creating and managing UML diagrams. You can generate UML diagrams in the platform for the class you have defined. Now let's go through the class diagram. So this is what it is supposed to look like. Let's check it out here. Okay, so class diagram and UML class notation. So you can see it here that first on top of the column we have name, then we have attributes, and then we have operations, uh, methods. So in case of attributes and operations and or methods, we have them here and as well as their return type. So in case of methods are returning void, or in some cases it can return an integer value. But since when a method does not return any value, then it is essentially returning void. Void means null or nothing, zero, that kind of thing. And in case it is returning some, maybe if the method is addition or something, then it will return int. And in this case, attributes are also recorded here with their data types. So yeah, and we also have this visibility notation. Plus stands for public and minus stands for private. You can check it out here. So yeah, you can read about it, and this is how it works. It is basically helpful to visualize the class that we have defined. So that is why we use these diagrams. Okay, so let's move on. Next up we have encapsulation and polymorphism. Encapsulation is the bundling of data, variables, and methods, functions that operate on the data into a single unit called a class. Encapsulation also restricts access to some of the object's components. Polymorphism, it allows one interface or method to be used for different data types or classes. Polymorphism literally stands for many shapes, which in context of computer languages mean that different objects can respond to the same method call in their own unique ways. So these were the technical explanations. Now let's make it such that we will find it easy to understand. For understanding encapsulation, you can think of a bank account. Now, bank account has data that is private, which is your bank balance. Meanwhile, there are methods like ATM, online banking, which allows you to withdraw, or deposit money or check balance. So these help in these, while the balance is a private data. And the bank account can be thought of as a class. So these can be thought of as public methods. To access the bank account, I mean the bank balance, which is the private data. Also, we know that bank account has your money secured. Like that is basically what private means. Like nobody other than you can check the bank balance. And if suppose you take out, you want to withdraw more money than you actually have, like the amount is more than your balance, so that will not be validated. The bank system will stop you since this operation is not valid. So, this can be thought of as restrictions to access, like the access is restricted through the bank balance being private, first of all, and then when you are trying to withdraw more amount than you have, that is also being restricted. So, this concept can be thought of as encapsulation. I hope it is clear. And for polymorphism, so for polymorphism, you can take the concept of vehicle. Now, this can be thought of as a class, and move is one of its methods. Now, vehicle can have objects like car, ship, airplane. Now, we know all of these move differently. A car is driven on roads, a ship sails on waters, while an airplane flies through air. So, for each of these, move has a unique meaning, even though all of them are essentially moving. So, this is how you can explain polymorphism. Like for the method of move, these objects of car, ship, and airplane are accessing the methods and they are modifying it according to their own characteristics. So, for the object of car, move means differently, slightly differently than the object of ship. Then we have public versus private attributes. Public. These can be accessed from outside and can be modified without any restrictions. Private. These are restricted from direct access. These can be accessed or modified only through getter or setter methods. These are prefixed with double underscores. Okay, so let's check out these. So if you remember the program from the last day, you can see that these attributes, this one, name and breed, they are public since we can access them from outside and they do not have underscore before the name. Okay, so let's write a different program. This is, by the way, kind of similar to the program that we had written 2 lectures back, I think. So yeah, it's just like it's basically that only. So let's write. So here I'm defining private attributes. Okay. So the definition is done because they have underscore before them. They are private attributes. Okay, let's write get brand self return self brand. Okay. So this is a get method. This one, okay. Let me just write it here. Uh, Getter method. Like we are accessing the private variable, private attribute. Next, we will have the setter method, which will modify the private attribute. So yeah, so let's just create an object of this class is equal to um okay, it should be my car. Let's just go for my car. Car say Maruti only. Okay, let's write print car dot brand. Now let's see what this results in. Yeah, so this will result in an error because we are trying to um, access the private attribute from outside, which is not allowed since it is private. So you cannot access it this way. You cannot write it this way. So this is wrong. Okay. Okay. So the correct way is print my car dot get brand. So you have to remember that we are calling this method get brand and printing it. So remember the syntax, like the two brackets of get brand should also be there and the bracket of the print function should also be there. So at the end of this statement, you'll have three brackets, two closing and one opening. So you can see, okay, let's write the whole program first. My car dot set brand Honda. So we can just write it this way. Okay, class, car, brand, and model. Just a second. Okay, I have made a mistake here. So, setter method is supposed to have the brand parameter, right? Else it cannot set the brand to brand, right? Okay, so since I just copy pasted it, I mistakenly had defined both the methods with the same name, and yeah, that is what went wrong. So yeah, you have to be careful with these sort of things. Like I couldn't even figure out where the mistake was. Like it happens, like you are actually so sure that you wrote it correctly, but maybe it gets wrong. So yeah, so get brand. So here we are to print the brand, we are supposed to write it this way and not the this way. Like you cannot just access the private attribute directly by creating the object. This is how you want to do it. And if, for example, if you had, I don't know, say color, which is private, public, sorry, equals color. So in this case, you could have just written this. Like since it's public variable, you can access it this way. And let's give the color attribute here. Say gray. Car, my car dot should be car, my car, my car dot color. Yeah, so since color is the public variable, you can directly access it. You don't need getter or setter methods. But for variables which are not public, you have to use getter and setter methods. And you have to be careful. Like I made a mistake and I couldn't figure out where it had gone wrong. So yeah, this was all about private and public variables, attributes. So let's move on. So in the last lecture, if you remember, we had learned about method overriding, where we had overridden a method when we inherited it from the parent class. There's another way of working with methods called method overloading. So it is basically a way for more than one methods with the same name but different parameters to exist in the same class. and the number or types of parameters are different. So it is a way to define multiple behaviors for the same method name based on the arguments passed. So let's check it out in the program. Let's say class calc. Also, I don't know if you noticed, but mostly whenever you see these special words that we are typing here, class, def, self, and last class we learned about CLS, these are like for words like for and if, which we use for conditional statements and loops. So even them, they are all written in small letters, not capital letters. So you have to remember this. Like no special character is written in capital letters. So yeah, class calc, and next we have def, add, self, a, comma b equals 2. So here we are using default arguments, if you remember what that is. A plus b. Alright, so let's say calculator equals calc. Like here there is no initialization. Here the class does not need the init constructor to initialize any of the attributes because there are no attributes. And in case like here we can just call the function and work with it. So let's go do it. Print calculator dot add say 2 comma 1. So 2 stands for, again we have to use two back brackets at the end because one for the function of add and the other one for the function of print. Okay, let's write the print statement again, and this time let's use say just 5. Okay, let's run and check it out. So here we are using the default argument, like I said, b equals 2. So the method behaves differently depending on the number of arguments passed. Here we are using two user-defined arguments 2 and 1, just giving us the result of 3. While here we are uh, inputting the value for A, but we are using the predefined or default value for B, which is giving us the result of 7. So this is basically method overloading because both of these methods look different and work differently. Like only because of the parameters passed. So let's try something different. Let's do ARGS. Okay. Return some ARGS. Okay. Right. Calc at 2 comma 1 and let's go 3, 2, 1. Let's check out the results. So here star args helps us to call the method using variable length arguments. We can call the method with any number of arguments without defining it beforehand. Like in this case, we are just adding two numbers, but in this case we are adding 5 of them. And so here we are not uh, using parameters like a or b, and in case of the return statement we are using sum args. So we are using the sum of args, and sum is a predefined function, by the way. So yeah. Alright, so now we have come to the end of this video and it's time for a quick recap. So we started off with UML diagrams, then we learned about encapsulation and polymorphism. Then we had public and private attributes, and finally method overloading. So we have ended the 5th module. As always, let me know in the comments if you have any queries regarding the previous lectures or this one. And I hope you remember everything we have studied thus far. Alright, so good luck to you and see you guys in the next video. Bye bye.